Another one together. Here I've got 2 nitrogen gas molecules reacting with 5 oxygen gas molecules to get 2 molecules of dinitrogen pentoxide gas. And if I look down below, I've got my 3 constituent reactions with their changes in enthalpy. So I'm going to do exactly what I did before. I'm going to go through, I'm going to kind of survey what's going on and see if things cancel, see if I need to flip, see if I need to multiply any of these equations. So let's check this out. Here I've got hydrogen on the reactant side, and I don't have any hydrogen up here, so that's kind of fishy. I might end up, canceling that out eventually, but we'll see. I do have oxygen on this side, and that's quite nice. So I'm going to keep that. There's oxygen on the reactant side, just like there's oxygen on the reactant side here. And then on the product side, I have a water molecule, which I don't know where that goes. All right, there's no water molecule up here. Maybe it gets canceled out later. Well, we'll just have to go. But right now, because that oxygen is on the reactant side, that seems pretty nice to me. So I'm just going to leave that reaction alone for right now. Now this one is key. Here I've got my dinitrogen pentoxide gas, and it's reacting with a water molecule, and that's giving me 2 molecules of nitric acid. Well, if you look at my summary equation, my dinitrogen pentoxide is on the product side. Here it's on the reactant side. So what should we do? Well, you guessed it. We're going to go ahead and we're going to flip this equation. Okay? So if I flip this equation now, I've got 2 molecules of nitric acid, and that's going to give rise to my N2O5 and my water molecule. Now if I flip that equation, and I'll put a little note here that we flipped that, okay? If we flip that equation, I got to make sure that I change the sign of my enthalpy. So now my new enthalpy is going to be 76.6 kilojoules per mole. All right, awesome. Now I'm going to make it a habit of when I manipulate an equation, I'm going to go back through and I'm going to scratch it out. I don't need it anymore. I've already manipulated it. I'm not going to use it again. Great. Now, let's go down to my bottom equation here. I'm going to kind of survey the scene. Well, look at this. I've got a half of a nitrogen gas molecule. That's nice. It's on the reactant side just like it is in my summary equation. I've got 3 halves of oxygen gas molecules, and that's nice because, again, my oxygen is on the reactant side of the equation. And I've got a half a molecule of hydrogen, and if I look at my summary equation, there is no hydrogen gas, so it probably ends up canceling eventually. We'll just see how it goes. Let's just bear with me. Let's check this out. And I've got nitric acid as well. Well, I like the way this is lining up because I do have my nitrogen and my oxygen on the reactant side, so I'm actually going to leave that equation alone. But the only thing is that I need to somehow I need to cancel out the hydrogens. And the only way I can do that is if I flip this equation as well. So I'm going to go ahead and flip this equation. Okay, this is a little bit more difficult problem, but you'll be able to figure it out. We're going to practice, practice, practice. So now I'm left with water molecule, and that's going to give rise to my hydrogen gas and my half oxygen molecule. Okay, so things are looking good so far. Okay, now if I flip that equation, you guessed it, I have to flip the sign of my enthalpy. Good, so everything's looking good so far. Okay, all right, well now I need to get rid of my 2 nitric acid molecules, and somehow I need to get rid of my hydrogen molecules as well. Well, as you can see, is if I multiply this entire equation by 2, I will have enough hydrogen and I will have enough nitric acid to cancel out. So I'm going to go ahead and I'm going to bring this down here. Alright, so now I multiply this entire thing by 2. I've got 1 molecule of nitrogen, 3 halves times 2 is 3 oxygens. I've got now 1 molecule of hydrogen, and all of that gives rise to 2 molecules of nitric acid. Now, if I multiplied my entire equation by 2, I've got to multiply my enthalpy by 2, and if I multiply that by 2, that is negative. Let's see, negative 348.2 kilojoules per mole. All right, good. Things are starting to look up. I know it seems pretty daunting right now, but let's go ahead and just stick with it. I've flipped and I've multiplied and I've manipulated all these equations up here, so I'm not going to go back to these equations at all. I'm not going to use them anymore. Everything's been changed the way I need to change it. Now, all I'm going to do is I'm going to go through and I'm going to start canceling things out that can be canceled. All right? So if I look here, I've got my 2 nitric acids and 2 nitric acids here, and I look up here and there's no nitric acid here, so I know it's got to cancel. So I'm going to use this. I'm going to cancel these bad boys out like this. All right? Notice they're on 2 separate sides of the reaction arrow. Okay? Now I'm going to look and I say, whoa, I've got a water molecule here and a water molecule here, and there's no water molecule up here. So my water molecules that are on opposite sides of the reaction arrow must cancel out as well. So I'll go ahead and cancel those bad boys out. Awesome. Now I'm starting to see some of the parts of my summary equation come together. I also noticed that I've got some hydrogen here, and that hydrogen doesn't exist in my summary equation. So turns out this hydrogen molecule is going to go ahead and cancel out this hydrogen molecule. Now what you'll notice is I have some oxygen on my reactant side, and I have some oxygen on my product side. But up here, I don't have any oxygen on my product side. So that must mean that this half oxygen molecule must cancel out. And if this cancels out, this turns this 3 into 2.5. And you're thinking to me, wait a second, how can you have 2.5 molecules of oxygen gas? Well, hold on a second. Let's continue to work through. So what I'm going to do now is I'm just going to go ahead and circle the things that are going to make up my summary reaction. I've got my dinitrogen pentoxide, I've got my nitrogen gas, I've got my oxygen here. Alright, so let's see if we can put this together. If I write my summary equation, I end up with N2 gas plus 2 1/2 oxygen gas molecules. Put together, we get 1 molecule of dinitrogen pentoxide. And when I add all these enthalpies together, I end up with a new change in enthalpy of positive 14.2 kilojoules per mole. Well, I'm not quite done yet. I don't feel quite comfortable because if you look at this equation down here and this equation up here, they're quite different as far as their coefficients. What you'll notice is if I want to get rid of this 2.5, I need to then multiply this entire thing by 2. And so what I'm going to end up with is I'll end up with 2 molecules of N2 gas. I'm going to get 5 molecules, 2.5 times 2 is 5 molecules of oxygen gas. And that's going to give rise to 2 molecules of N2O5 gas. And that's pretty nifty because if you look here, now my summary equation down below is exactly the same as my summary equation up above. So I know that I've done the work, I've done the manipulations that I need to do. But if I multiply this entire equation by 2, that means I have to multiply my entire heat or enthalpy by 2. And so when I do that, I get my final change in heat energy of 28.4 kilojoules per mole. And so this right here is my final answer for this particular problem. Lots of steps involved, lots of little rules to follow, flipping, multiplying, all this manipulation. If you keep practicing and if you keep coming in for extra help, I think it'll really make sense. This video is just to get you going, to get you familiar. I want you to go back, watch this video again, follow along, do the problems as I do the problems, and see if you can't take these concepts and use them on the worksheet. I hope this helped. If you have any more questions, again, come in and get some help. This is Underwood, signing off.